All right, in this video, we're going to examine the behavior of exponential functions when they're in the form of a times b to the x. In other words, how does a change what our graph looks like, and how does b change what our graph looks like? So I'm going to start with pattern number 1. And so what we're going to do is we're going to begin with 2. I'm going to make 2 my y-intercept. In other words, the value of y when x is 0. So I'm going to start with 2, but it says triple our amount every time. And we should know that tripling means times 3. So what I'm going to do is I'm just going to take 2 and I'm going to multiply by 3, and then I'm going to multiply by 3 again, and then I'm going to multiply by 3 again, and then I'm going to multiply by 3 again, and I'm just going to keep going. And honestly, I should probably get a calculator to do this because I can't do 162 times 3 in my head, but 162 times 3 would give us 486, and you can just see that these numbers are really shooting up fast as we keep multiplying by 3 over and over again to the point where now we're in the thousands, right? And so I could keep the pattern going by just dividing by 3 in the other direction. So that would be 2/3, because 2 divided by 3 is 2/3, and then that would be 2/9. And so what we have is this. Let's kind of plot these points on a graph. I kind of want us to see what this looks like visually. But first, let's write the equation. And what we should know is that our function takes the form of y equals a times b to the x, where that a value is your y-intercept. At least in this form, it's your y-intercept. It's the starting amount. So it's the 2. And the b is what we call the growth rate. That's the number that you're multiplying by every time. Since we're tripling, our growth rate is times 3. So we have 2 times 3 to the x. So as I graph this, I'm just going to plot these points and see what it looks like. So I'm going to start with the point 0, 2. We'll put that there. This is going to be a very rough sketch of the graph. I don't have any y-axis marked. I don't have any x-axis marked. But let's say we have 0, 2, and then 1, 2, 3, 4, 5, 6, 7. Let's just see what happens. Then 1 is at 6. 2 would be at 18. 3 would be at 54. 4 would be at 162, and once again, I'm just eyeballing these. 5 is going to be so high up the graph we can't even see it, right? But then I can keep going to the left and put negative 1 2/3 and negative 2 2/9. So negative 1 2/3 and negative 2 2/9. And so I'm just plotting these points. So I really want you to see how this graph has a curve to it. This is an exponential function. It's going to start with small amounts, and then when you keep multiplying by 3, boom, it's going to take off eventually, right? And so I want us to know that when we have this, we're starting with a positive, so we're going to be right here, and then by multiplying by 3 over and over again, it's going to cause that function to really increase quickly to the right. I'm wanting you to think about the relationship between this number, and the graph. On the second one, it says begin with 20. So we're going to begin with 20, but we're going to halve our amount every time. In other words, you're going to multiply by 1/2. It's the same thing as dividing by 2, but I just want us to think of it in terms of multiplication. So if I divide by 2, I got 10. Or excuse me, if I multiply by 1/2, I get 10. If I multiply by 1/2 again, I get 5. Then I get 2.5. And then I get 1.25. And then I get 0.625, and you see now these decimals are decreasing. We're getting super close to 0, but we're not quite there. And then we could continue the pattern the other way just by multiplying by 2. That means this number before here must have been 40. The number before that must have been 80. And so let's just kind of get a rough sketch of what these look like. So I'm going to start with 0, 20. So let's say 0, 20. Let's say 0, 20 is right there. So there's our first point. And then I'm just going to put 1, 2, 3, 4, 5, 6, 7, 8. So then the point 110 would be right there. 2, 5, 3, 2.5. And you see these points, golly, they're going to get so stinking close to the x-axis, but they're never quite going to get there. And if I wanted to put these 2 points, I could put them up here negative 140. It would just be negative 140 would be there. And then negative 280 would be, way up here somewhere. But our graph now is going to look like this. So we started. Actually, let me get our equation first. I really want us connecting those dots. if our function takes the form of y equals a times b to the x, that in this case we started with 20, and then we multiplied by 1/2 to the x power. Now, what I want us recognizing is that we started with the 20, so we're here, we're over here in the positives, we start with a positive y value, but then when you multiply by 1/2 over and over again, your graph's going to take a shape like this. It's going to approach 0. Okay, see how these numbers are getting smaller and smaller and smaller? One of the ideas I want you to think about is, when would this graph actually cross the x-axis? When would it actually get to 0? And hopefully if you're thinking about it, you're saying, man, I don't think that graph ever would touch the x-axis. If we keep taking these numbers and chopping them in half, we keep getting infinitely small, but we never quite get to 0. You can never take anything away. If you multiply by 1/2, you're always going to have something, right? So now, yes, so our main idea here is recognize that when you multiply by 1/2, our graph's going to look this way. We're going to decrease as x gets bigger. 2 more graphs. We're going to keep rolling. Now we're going to do, starting with -1. Oops. Now we're going to start with -1, and we're going to double every time. So -2, -4, -8, -16, -32, -64, -128. And then we could just keep going the other way. That would be -0.5 and -0.25. Our equation, if I did my equation, y equals a times b to the x, we know that we start with -1, because that's the value of y when x is 0, and then we're going to multiply by 2 to the x, okay? And so we're starting with 0, -1, which would be right there. So let's go, let me put some little lines on my x-axis. 1, 2, 3, 4, 5, 6, 7, 8. So we got this point first. 0, -1 is right there. Then 1, -2 would be there. 2, -4 would be there. So I took this point right here, 2, -4, and I plotted it right there. Then we've got 3, -8. So 3, -8 might be a little easier if I had some lined graph paper, but 3, -8 would be right there. 4, -16, and then we're already down to 5. My 5, -32 is already way off the graph, right? And so our graph this time is going to look like this. Now notice, we started with a negative. That means we're starting on the bottom side of the x-axis. We started with a negative, and as we multiply by 2, our values can get further away from 0 every time. So it's still going to have that swoop. It's still getting further from 0, but now it's down in the negative direction because we started with a negative. I want you thinking about that, okay? And this is our last example. We're going to start with -60 this time. So we're starting with -60, and we're going to halve our amount every time. In other words, we're going to multiply by 1/2. -3.75 times half would be -1.875. I know it's getting hard to read. And then that times 0.5 would be -0.9375. But then we could carry our pattern the other direction just by doubling it. So we'd have -120 and -240. And so if we have y equals a times b to the x, we know that the a value is whatever we started with. In this case, it was a -60. And this time we are multiplying by 1/2 every time. So let's see how this behaves on the graph. Let's see what the 1/2 does when I start with a -60, in other words. So let's say I make -60 right there. So we start at the point 0, -60. That point that we start with, I've plotted on my graph right there. And then, let's see, x equals 1, 2, 3, 4, 5, 6, 7, 8. So then let's go to the order pair 1, -30. So I go 1, and then -30 would be about right there. I'm just eyeballing it. 2, -15. 3, -7.5. 4, -3.25. 5, -1 point something. And man, we're getting so stinking close to this x-axis right here. So my graph would look like this. We started with a negative. So we're down here on the bottom side of our x-axis. But every time we multiply by 1/2, don't we get closer and closer to 0? So our graph's getting infinitely close to 0. And once again, I hope you're asking yourself, when does this touch 0? When do we actually get to 0?
And the answer is that we never actually do. This number's going to keep getting smaller and smaller and smaller, but it never quite gets to zero. It gets infinitely close, but never quite touches it. Now, I want to summarize what we learned. I want us to make predictions about what a graph will look like based on A and B. And this would be a good thing to put in your notes. So let's say we have a graph. We start with a positive A value, but we're multiplying by a fraction over and over again. Your graph's going to look like this. Okay? You start with a positive, but as you multiply by 1/2 or by a fraction or by something in between 0 and 1, like 0.8 or 0.2 or 1/6, your graph's going to go like this. It's going to get infinitely close to 0, but it's never going to quite touch it. Next, once again, if you take that positive A value, so we're taking a positive number right here, you have a positive starting number, but now we're multiplying by some number greater than 1, like doubling a number or tripling a number. Now your graph is going to start positive, but it's just going to get bigger and bigger and bigger. Now we're going to make some graphs kind of like our last couple of examples. Now we're starting with a negative, but multiplying by a fraction. I think on the example we did, we started with negative 60, and then when you multiply by 1/2 over and over again, it just got infinitely close to that line, but never quite touched it. And then we had our example, I don't even remember what we started with, but we start with a negative number. I start with an A value that's less than 0, so I'm going to start with some number down here, but then we're multiplying by a number like 2 or 3, so we're just going to multiply by that number, just get further and further from 0 the further we go. Okay? Now, a term that we need to know is this says all exponential functions have a horizontal blank, which is an invisible line that the curve approaches as it heads towards infinity. So, for example, we said that this graph is going to get really, really small, but it's never going to quite get to 0, right? That's because there's this invisible line along 0, really in all of these graphs, that our graph's going to get super close to, but it's never going to quite touch it. And that line, that dotted line that I drew for all these, and I'm not making this up, that's called an asymptote. Okay? Now, what we're going to do is I'm going to give you 4 examples, and I want you to predict what the graph would look like. So, for this one, I'm giving you a function in the form of a times b to the x, where a is 2 and b is 3. So our function in this situation is 2 times 3 to the x. I want you to draw a rough sketch of what you think that will look like. Hopefully what you're saying is I'm going to start at 2, because that's where we start at. That's our y-intercept. And then if I triple it every time, that's going to cause this graph to increase really quickly. So our graph is going to look like that. Okay? As you multiply something by 3 over and over again, to get further and further from 0. Your next example, now we're going to start with negative 2, but we're going to multiply by 3 over and over again. So your function this time is negative 2 times 3 to the x. So once again, draw a rough, predict what your graph would look like, and then see if you're right. So start at negative 2, and then if you multiply that by 3, you'd have negative 6, negative 18. Basically, your graph is going to be one of these. If you're down in the negatives and multiplying by 3, your graphs just get further from 0 in this direction. You're starting in the negatives and getting further into the negatives. Now, if you started with 4 and you multiply by 0.2 every time, in other words, what if you had y equals 4 times 0.2 to the x? Well, if you started with 4, you'd be there. But then when you multiply by 0.2, your value actually gets smaller every time. This is the number that we're multiplying by over and over again. So your graph would start big, but every time you multiply by 0.2, it's going to get closer and closer to 0, but it's never going to quite touch 0 or get to 0. So I just want you to know that this is what our graph looks like. It's going to have that y-intercept of 4, but it's going to get infinitely close to 0 because we're multiplying by a fraction. We got to recognize if we're multiplying by that number that's in between 0 and 1, it's going to get super close to 0 but never quite get there. And then lastly, let's start with negative 4 and multiply by 0.2. So we have this function this time, negative 4 times 0.2 to the x. So you're going to start at negative 4. And now when you're multiplying by 0.2, it's going to get closer and closer to 0, but now we're kind of approaching from this negative side right here. And it's going to get infinitely close to 0, but it's never going to quite touch it. And I think that's about all I have. I don't think I have another slide, but just kind of know, I want you to be able to recognize how A and B affect the graph of these exponential functions and know which of those four categories it's going to fall into based on that table.